All right. Happy Thanksgiving, everyone. It's quiet here at our place, so I decided to do some editing and might as well go ahead and record the session since I'm working on it and you could possibly learn something from it. So let's switch over and take a look at what I've got going on here. I got a new piece of hardware called the Star Adventurer, which is a tracker. So it allows me to take more exposures because it rotates the camera as the Earth's rotating. So I got these captures zoomed in on Orion. This is the belt. You can see the great Orion nebulas right here. So we've got that going on. But if we look at, I always blink my data before I go through it, and these are 45-second exposures. And if we look at this, we've got some pretty bad frames. So there's a few things going on. I had clouds, I had some tracking issues, probably me bumping into the tripod. So I only had a few really good frames. And so just to be clear, when you have bad data, the best thing to do is to get good data. In other words, bad signal, you can only repair so much. And what I want to show is how I can work with bad data, just in the case that you have some data that's hard to recollect or whatever. Ideally, before I publish this, I'll probably go out and do more captures and get it right and get a lot of really good signal. But let's see what we can do with some bad signal. So I pulled out just a few frames, I think it was about 5, and I stacked this, and this was the result that I got. And let's go ahead and go full screen so you can see that better. I'm gonna expand this out and stretch it. Let's go to, all right, so this is the stretch data. And you can see we've got some glow going on here. We've got some splotches. I didn't take flats, so the splotches are out. Let me zoom in, make it easier to see. So there's a little splotch kind of right here. That's a little annoying. So, and the color's off. So what am I gonna do to fix this? Well, the first thing I'm gonna do is crop the image. So I'm gonna super saturate it. I'm gonna use this radioactive icon here to take it next level so we can really see what's going on. And notice there's this kind of line along the bottom here and line across the side. So I want to go ahead and trim those out and just get the decent data. So I really wanted to, in this case, capture kind of all 3 stars on the belt, but this is right on the edge, so it's just not going to work out at all. So what I'm going to do is bring this in. So this star here is the one that the Flame Nebula and the Horsehead Nebula may or may not appear on, so we want to keep that. We can trim the top a little bit here. We'll bring in the edge here, and we'll bring this up like this. So let's go ahead and apply that. So I'll take my dynamic crop and just check it. Okay, so we're getting closer. The next thing I like to do is just go ahead and normalize the colors. So what do I mean by that? If we look at statistics for this frame, we can see that the green is a stronger signal than the blue and the red. I can tell that by looking at it, but this kind of confirms it. So we want to level those up. I created a script. So if we go into script, deep sky workflows, I have this auto linear fit. And what this is going to do is it's basically going to separate out the red, blue, and green channels. So they'll be separate. It's going to pick the channel with the weakest signal. I could do the strongest or the weakness. I like to sort of use that one to bring the other levels closer to it. Then it's going to do something called linear fit, which is going to average the intensity out in the other channels. And then we'll combine it back together and hopefully have a cleaner color. So this just automates that process. You can do each step manually, but I prefer to go ahead and script it like this. So there it's splitting the channels. You can see down here, it's actually picked the channel red as the weakest channel. It's applying linear fit to green and blue, and then it's going to combine those channels back. So we'll let it finish, and then we'll stretch it again. And now it's a little bit more natural color. In fact, we've got a really nice coloration coming through on the Great Orion Nebula. So even just these 45-second exposures did well. So the next step that I want to do is deal with this background. So I'm going to go into Dynamic Background Extraction. And I'm going to take the tolerance up high because I'm not automating the squares, I'm doing it myself. For shadows relaxation, I want to pull in more darker pixels into the background, so I'm increasing this a bit. Sample generation 30 looks good for that. And then for target, because it's a vignette, because this is a circular, it's not a linear, it's a circular, I'm going to use division instead of subtraction. So the key to this is to really sample areas where the gradient is. So like it's dark in this edge, so I want to grab some here and come down to this edge so it can sample and see what's going on there. And then I'm just slowly working my way inside. Now I could increase the stretch a little bit. Let's see what that looks like. And so I get just a better view. Like I can see the flame nebula here. I'm not sure if it's going to show through on video, but there's some faint texture there, so I don't want to put a block on that because otherwise it'll zero out the nebula as the background. But let me go back to the normal stretch. So we're working around that, we're bringing it in. And again, the key is to just sample areas of background, trying to avoid stars. If you catch a few though, it's not the end of the world. And I'm just sampling these across the gradient so that it can build the proper model for that. So I'm going to do a few more. And like I want to get this corner up here because that's dark, and then the gradient kind of shifts through here. And I'm giving it the information it needs to be able to build a working model of the background and subtract it out. And finally, I'm closing up on this side. And this is one of those operations sometimes you have to redo because you might do it once, find out it doesn't work out, and do it again. But I think we've got a pretty good set of samples. So let's just hit the check mark and apply it. Then we close this out and we stretch again. And you can see it made a huge difference. We've got a lot of background noise, but we've evened it out. There's a little bit of a arc here. That's fine, we'll deal with it. But we've got our stars, we've got our nebulosity. Now this is going to need a lot of work, but let's go ahead and take two more steps. The next step is neutralizing the background. So I'm going to grab a piece of something representative of the background, something like right here. Doesn't have to be huge. And then I open up my background neutralization. I select that preview, and we throw that. And what that's basically doing is it's trying to average out the background so it's a little more even. We're not trying to make it completely black, but we are trying to even it out a little bit. So we've done that. Now we want to calibrate our colors. And you've got two options for color calibration. You can do photometric calibration, which is my favorite because it's based on a database of existing data, or you can do regular color calibration. for regular color calibration, you can either draw a preview over some stars or use the whole image. I'm just going to use the whole image. So for my white reference, we're going to use the image. For my background reference, I'm going to use the same preview I used for background normalization. And we'll run that. And then you always want to stretch after you color calibrate so you can see. And that's what happened. And it probably didn't even show up on the video. It was so subtle, the change. Let's undo that. And let's see if we can do photometric calibration. So what I'm going to do is pull this up. So I've got to give it a reference of coordinates. And we know that, and it should be kind of near the center, we know that the Running Man Nebula is right here. That's NGC 1977. So let's go ahead and search for that in the database and get that. So now we've got these coordinates. We need our observation date. I did this just a few mornings ago. I don't really care about the time. My focal length, I was zoomed in, so I know I was at 212 millimeters. And I know that the pixel size for my camera is 3.9. So hopefully this gives it enough, because it needs to plate solve, which means figure out where in the sky this is, and then it can compare to the database. So we're going to run this. I'm going to move this out. And we're getting these grids. That's how you know it's working, because it's just trying to hone in on a better example. So it is actually able to figure out the dimensions of this image, which is great. So now what it's doing is it's going out and it's finding similar images to analyze the various colors of the stars so that it can apply a correction to bring this more to what's sort of the accepted norm from the database. So it's going to have to find similar images, stretch them kind of to compare apples to apples. And it's applied now. And it's done. And you can just trust me that it worked with the colors. Okay, so now let's deal with these stars. The stars are a real problem. This is my bad. I had a tracking error. And so if we look at our stars, let me zoom into the Running Man Nebula. You can see there was some tracking, so they're all elongated. I can't perfectly fix it, but there are a few things I can do. First thing I'm going to do is deconvolution, which is designed to get the stars closer to their actual shape. And I have a script, again, as part of Deep Sky workflows called Generate Decon Support. This gives me all of the masks and different pieces that I need to run decon. Now I could tell it to start a dynamic PSF. That's what this section is for. I'll basically run through this section. So it's going to extract the luminance to create a luminance mask. That's needed so it can pull the stars out. And it gives you the option if you've already done that. We want the mask to cover the stars. So what's going to be generated is like a snapshot of the stars, because I use something called StarNet. So we want it slightly bigger so it can overlap. If it's a really dense star field, I'll only grow it one iteration. Because this one's a little lighter, I'll grow it two, and I want it to blur to soften the edges. If I'm doing a dynamic PSF, that's me selecting the stars, I'll use this section, but I'm going to just generate it using a script I found. And then we're doing a support mask, and I'm going to launch the process so it's ready to go. So let's run that. You can see it's creating the masks. Now it's running StarNet, which is down here, these image tiles. It's taking this image and it's computing what's star and what's not star, and it's going to split it out. So you'll have an image without the stars and you'll have an image with the stars. And we're going to use that a little bit later as well. But it's pulled out the stars, created my mask. Now it's just generating the decon support, which just gets the higher intensity stars, which is what this is. And my deconvolution dialog has popped up pre-populated. Now what the dialog is missing right now is what's called a point spread function. So we have two options here. we can generate a point spread function and try to approximate the shape of these stars. And there's a script online that I have that allows me to render a PSF image. You can play with the sensitivity, whatever. We'll just click evaluate. What we want it to do is grab a substantial number of stars. Here we've got 647, which is a pretty good star count right here. And it's analyzing the stars, and it's going to pick kind of what it thinks the best representative stars are. And then out of that, we'll get a point spread function, which is an approximation of what all of this looks like. So okay, and there we go. And you can see how this is angled, just like these are angled. So we did well. We got a good point spread function. So I'm happy with that result. Let me go ahead and create this and click OK. So now we can select our PSF here. And it comes into here. So let's pull up our preview. I'm just going to run this on the preview at first to tweak it. So I'm going to select that star mask that I generated. You can see it's solidly covering the stars. I'm going to hit Control K to remove the mask. And I've set this up for reasonable defaults in my script. So hopefully I can just run this and get a good result. But if not, we'll tweak it. And you can see here, let's zoom in. And let me see if I can do this. I want to show you, basically take a look at this area right here with these 3 stars, and I'm going to toggle it before, after, before, after. Now it didn't make them perfectly round, but it certainly tightened them up. So I like that result. I don't think I need anything else. I'm going to go ahead and run that. And again, for those tuning in a little late, I know the video will be posted and you'll be able to rewind or whatever, but this is some really bad signal. And again, I want to emphasize the best way to fix that is to take new captures, make new observations, and get better quality data. But this is a great opportunity for me to show you some of the tricks that I've learned along the way. Okay, so we've sharpened the stars. The last thing I'm going to do before I stretch this image, and if you're not familiar with what stretching means, if we look at the histogram for this image, which is here, and I'll explain histogram in a second, and there we go. So the histogram just shows you the distribution of pixels. So if we reset this and check it, you can see basically this line is way over here. All of the pixels are crammed to the left edge. That means all the distribution is low intensity. This is artificially amplified so that I can see it. And the human eye, of course, wants these to be more spread out for contrast and definition, so we stretch that. But before we stretch, we want to get rid of the noise. And we've got a lot of noise here. See how this background is really grainy, and there's these chromatic aberrations and grain aberrations. So we want to address that. So the first thing we need to do is make a mask. The dark areas are the ones that have the noise. The light areas have signal. So we want to prioritize this so that it's basically just mainly working on the dark areas. So what we'll do is I'll remove the mask that's on there. And again, I'm going to use a script of mine that creates a Luminance Mask. What this is going to do is stretch the image and then pull out the luminosity. So we'll do that. And now we have this mask that we can use, and it's appearing like that because it's stretched. So here's the mask. I'm going to apply a change because right now the bright points completely protect and the dark points completely open it up basically for this. And we want to kind of settle it down so there's no perfect protection and there's no zero protection. So the way we can do that is we can open up our curves here, and the curves is a transformation, and the diagonal line means it's 1-to-1. You can see input to input. What I'm going to do is I'm going to take this and just raise it up, and then I'm going to take this and I'm just going to raise it down. So this gets rid of the extreme edge cases, it kind of squashes things in the middle. So if we apply that, you can see it turns a little hazy, but this is the mask that I want to use for doing my noise reduction. So we're going to go ahead and apply that mask. And this is going to be this L mask here. And if we Control K, we can see it's protecting the background. So we Control Shift I to invert it, and now it's protecting the foreground. So again, we'll go to our preview so we can see our progress. And actually, sometimes it's better to have a preview that covers a nebula so you can make sure you're not getting rid of the details of the nebula. So we'll use this one. I'll zoom in a little bit. And what I'm going to do is a multi-layer transformation. Now I've got the numbers jacked up pretty high on here, but there's two transformations. Luminance will address all of this graininess. Chrominance will address the red, green, and blue pixels that you see distributed. So let's try luminance first. I'm just going to drag it onto the preview, so it's just running on this small section. And it's going to take a little while to process. I should have some hold music or some entertaining interludes, but we'll just give it a second. Okay, so it's processed. So now what we can do is we can look at this and we can toggle with this button back and forth. And notice how those dark spots just kind of disappear. If you're seeing that. So that's actually a good result, but it may make the image look a little artificial. This is a pretty strong and noticeable stretch. So let's do this. Let's take it down a little bit. So this amount here on the dialog is how much of the signal to apply. I'm going to take everything down half. So that's going to go down to about 0.5. This is going to go down to about 0.45. This one will go down to 0.4. So I'm just reducing the impact of this noise reduction to make it a little more subtle. I want to get rid of the noise, but I don't want the image to look plastic and fake. So let's take this and finally here. And I'm going to run it on my preview first just to make sure that I haven't completely gotten rid of the impact that this has. We want it to make a difference. And we can see it's definitely still working well. So let's go ahead and apply it to the entire image. And again, this is just addressing the graininess. We're still going to have, in fact, it's probably going to really pop out that it looks like really crazy colors here in a second. Yeah, it's actually not too bad. So if we pull up our preview, that's applied. Now we've got all this chromatic aberration, these colors. So let's just change this target to chrominance and run with the same settings for now and see how that works out. So what it's doing now is it's processing the channels and looking at how the colors are distributed, and it's normalizing those colors based on the mask. So again, the dark areas are going to get more treatment than the lighter areas. So we'll let that run. It's got 3 channels to do. It's already finished the first 2 channels. We're processing on the 3rd channel. We're almost there. And look at that. So let me zoom in. I'll get this over here. Oh, I just closed it. That was dumb because I need to reuse it. But if you look at this chroma, and it's really just smoothing that out and getting rid of those values. So I'm going to go ahead and apply it on the whole thing, but of course, because I closed it, I need to go ahead and resettle my values here. I should actually just save this icon off and have one full strength and one half strength. That's kind of a tip that should help out, but no worries. We'll get this down. We'll get this one down. And this one down, and then we're going to click this to go to the whole image and go ahead and apply it to everything. We'll let that run. Now, interestingly enough, and this is just a theory of mine, I notice if I run it on previews, I think it tends to run faster on the whole image. So I don't know if it has to do computations that it remembers, but it seems to go a lot faster. So there it's done the whole image. So I've tightened up the stars, I've reduced the noise. Now we're going to stretch this and start to work on bringing out the details. I like to use a tool called Easy Processing Suite. There's a denoise, there's a HDR, which we might use, but there's this soft stretch script, which is a great script. Let me actually show you how to stretch manually first. One thing that you're going to notice is after I applied these changes, I didn't apply the stretch, and the stretch is going to make it look horrible. Let's reapply it. Well, actually, it wasn't as bad as I thought. But let me take out what's called the screen transfer function. That's basically what we're running when we hit those radioactive buttons. We're running this, and this is what's stretching this to make it visible to us. Now I can take my histogram that I showed you earlier. So this is the histogram for this diagram, and I can tell it to pick up the changes from this stretch. So I just drag this down here, and now it's got a new curve based on the stretch. We can preview that, and this is double stretch, so we'll take off this, and we can see in the preview just what this is going to look like. Now we need to make sure that we don't have a mask applied, which is what I think is happening here. So let me remove the mask, preview it again. Okay, so that looks much better. Now what you can do is we've got these sliders to work with. Notice down here, shadows, I'm losing 151,000 pixels because this one is actually chopping off. By sliding it here, I'm cutting off these pixels to the left. I like to try to keep as many of these as I can because they may contain detail and signal. But this one we can drag out to the right, and that'll make the image darker. Now it's a trade-off because the nebula can fade away. And the closer these are, the more contrast you have, so the more easy it is to see the nebula, but the more you risk of losing channel. So that's how you do it manually, and I would click this square button and it would apply. Using the script, however, I can go in and do easy soft stretch. And I noticed that there is at least one person watching, so if you have questions, I am keeping an eye on the chat too. Notice this looks really nice. I don't know the exact algorithm that they use, but basically if we slide the target median up, it's going to preserve more of the luminosity. This is going to be more of a contrast. I might just nudge it a little bit and just make sure I'm not losing a ton of detail. Let's go ahead and run that. Now the image is stretched and we've got something closer to what we want. So we need some final touch up. Right now the flame nebula is really faint. You can kind of see it here. My stars are still irregularly shaped despite the deconvolution, and I just want to draw out some more intensity. So what I usually do is what we call multi-frequency processing. Our high frequency is the bright areas, which is the stars. Our lower frequency is the nebula. So what I'm going to do is I'm going to take this, actually let me close some of these other images because we're going to create a new set of masks and everything to work with the stretched image. I'm not even going to use that star mask because I can create a new one. So we'll do this. Close it. Just make sure I'm not closing my work. Going to close that. We don't need the point spread function anymore. I'm not even sure where the point spread function is, because when I click here, oh, I think it appeared somewhere off screen maybe. Anyway, not too worried about that. I'm gonna delete the previews. Let's go here, delete all. All right, so what I'm gonna do is drag this here to make a copy. That way I can go back to the original if I need to abort for some reason. I'm going to take my star net. Where's my star net? Da, 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 da. There it is. Drag that on here. Now, it's basically StarNet with the default settings, but what I've done is I've set it up so that it creates the star mask. So we're going to get the version of this with just the nebula, and we're going to get the version with the stars. So here's my stars right here, and here's my nebula. Let's look at the nebula first. What can we do with this to draw it out? A few things, and this is totally live, so I experiment, I try things. They sometimes work out, sometimes they don't. One of the tools I like is the local histogram equalization. And I'll show you what that looks like, because what I can do is draw a preview over these two, and then I can take my local histogram equalization, click on the preview, and first it's going to look terrible because the kernel radius is shorter. It's made it kind of grainier. But if we increase this so it's taking into account more of the image, it'll smooth it out a little bit. Let's let that process. So before, after, before, after. It's brightened it up a little bit, drawn out maybe a little more detail and contrast. We can also bring down the effect that it has so it's not so impactful, doesn't bring in so much noise. That's a little bit better like that, so I like that result. So I'm going to go ahead and go to the full image and run this. And we'll see what it does with the Flame Nebula down here. There's actually the Horsehead Nebula should be visible as well, but I'm not sure I can tweak it enough to pull out the signal. If you're watching this and have tips for bringing in that really faint nebulosity, I mean, I know a few ways to do kind of selective masks and whatnot, but trying to keep this more straightforward for now. Okay, so we've done the local histogram transformation. Now there's another few steps that I can take. One is I can use the curves, and again this is a transformation going from one to another. So if I pulled this whole thing down, it's going to reduce the luminosity of the entire image, and I'll just completely lose my nebula. But there's a trick, and what I can do is I want to make the nebula areas brighter, and I want to make the background darker. So I can click, make sure I'm on L here, which is for luminosity. I'll just highlight that right there. And then what I'm going to do is I'm going to click here. And notice that bar appears. That's telling me the intensity. So the bar is right here. I'm going to click here, click here. We can see most of the bars to the left side of this line. If I click inside the nebula, it's way up there. So the trick is this. I'm going to put a point here. And then I'm going to, oh, what's happening? Let me restart this. For some reason, it's got one of my cursors is acting wonky. Okay. So what I'll do is, again, I'm just going to double check. I'm going to put a point here. And this is going to, when I drag this down, create an S-curve. Like that. And let me make sure I'm actually looking at the right image. So we're here. preview. There we go. So I'm not going to do it too extreme, but you can see if I do a little bit here, it starts to raise the intensity here and lower the intensity there. So we could actually do this multiple times and then it would wash it out, but that first iteration was useful. And now the next thing I'm going to do is use something called an Arcsin Transformation. Or Arcsin stretch, Arcsin maybe. So this stretch will try to preserve the colors and just increase the brightness. So again, I'll do a real-time preview so we can see what it looks like. And then we're going to estimate the black point. And don't worry about this noise. This is not going to appear in the final example, but notice how this nebula is sort of filtered out, if you will. And if we drag this, we can see the intensity increases. Now that's way too much, so I'm going to do just some fine control here. Let's do 1.1. Let's do 1.5. Already that's pretty bright, so maybe 1.4. And we'll apply that. So this is what the result is. I'm going to just shelve that. That may be the best that I can do for the background right now. There is one more trick. These little artifacts, these splotchy little white things that you see, are sort of the edges of the stars that didn't get pulled out completely, and we don't really need those. So we can do a range mask. So let's go to range selection. We can preview this range mask. And slide this down and just make sure that the nebula itself is covered. And we can smooth it out so it makes it a little fuzzy. Now from experience, I know for a fact that the range mask is always a little, if I went here, the range mask would actually capture more than what the preview shows. So I'm going to go just past where I want to land. And that should get me right to where I want to be. So if we look at our new range mask now, I can close the preview out. So here's my range mask. So what did I do? What does that buy me? Well, if I mask this now with the range mask, so it's protecting the background, not the nebula. We're going to do two things. First, I'm going to increase the saturation selectively of the nebula. So with this mask on, I'm going to go to S, which is saturation, just going to increase it, which is going to bring out some more vividness and color in that. So if we toggle, we can see it's definitely adding color. So we're going to do that. I don't want to keep saturating it because then it'll get blown out. Like you can see if I applied it again, that would happen. But now I'm going to invert the mask. Oh, and it looks like I was doing that to the wrong screen. Okay, let's try this one. I was doing it to the original image, or actually I just closed down to the original. So we can always check here on our history. And the last thing it saw was the stretch, so we definitely want to apply the saturation. I'm going to take it down so we could completely remove the color, but let's get a good level here. Apply that. Close this. Now with the mask on here, oh, okay, I figured out what I'm doing wrong. I was doing it to the main image instead of this. This is the one we want the mask on. So we want the range selection on this one. And then we can Control K. Oh, the joys of doing it live. Okay. So now we've got the controls that are just increasing the saturation of the nebula. I'm just going to do a little subtle tweak there. Apply that. And then I'm going to invert the mask. And I'm going to lower the luminosity of the background. So because the mask is inverted, it shouldn't affect the nebula, but it'll draw out the background. I'm just going to reduce it a little bit so that it's not as dominating. And we'll call that a wrap for this. For the stars, I'm just really going to do two things. First, I'm going to bring out some saturation in the stars because they really do have beautiful color. So if we come here, do our preview, go to saturation, I'm going to make them a little brighter. And I'm going to bring out just a touch of saturation. They're already pretty colorful with their natural colors. So just a touch. Now here's my attempt at fixing how deformed the stars are. If we zoom in, we can see they're still pretty deformed. So let's try this. Let's do a resample. We're going to pick the star mask. And I'm going to just double the size. Now notice right now it's 50993355. We're going to double it. And I'll show you why in a second. So let's apply that. Now that it's doubled, I'm going to pull up a preview to look at a patch of these. And I'm going to use a trick called multi-scale linear transform blur. So I'm not doing any noise reduction, but I've specified a bunch of layers because I want fine-tune control. I'm at the max layers of 16. And what I'm doing is I'm just removing layers. Now layers are a way of looking at the image at different scales. So layer 1 is a 1 pixel scale, and changes you make operate on that. Layer 2 is a 2 pixel scale, etc. So you can actually separate out your structures. Now right now I've been too aggressive in my blur, and you can see nothing there because I've taken out too many layers. So we'll start to restore them back, and you can see now the details are coming in at the level of the layer we want. And notice that these at this level are actually round. And this is where the elongation starts to come in. So I'm going to stop right there. I know it's a little blurry, but that's why I doubled the size of the image, because I can apply this. And I made a mistake because I just applied it to the preview. And we want to actually apply it to full image. That's okay. We'll go to the full image and apply that. So that's the first step. It's not going to do much for these bigger stars, but that. Now we can optionally at this stage look at MLT sharp. So we can sharpen it at this scale because we just got rid of the weird shape. So let's see what happens when we sharpen it. So if I look at the preview, it still looks pretty decent. So then what we're going to do is we're going to restore it back to the original size. So here we're looking at this 50993355. So we'll come back here, we'll resample it, and we're basically going to cut it in half. But we need it to be exact. So again, and go here, so 5099 and 3355. Okay, make sure we're on our star mask, and we'll apply it. So this is shrinking it back down to the original size. Okay. We've done a lot of work, and again, this may not be presentable, but I'm trying to show tricks for dealing with extreme edge cases. The last thing we need to do is put everything together. We process the stars, we process the nebula. So let me go ahead and grab Pixel Math. And there's a pretty complicated equation that we use to recombine these. Now I know there's different ways people like to do it. I'm going to show you my favorite way. That is to, first off, let's remove the mask. $T refers to the target. So I'm going to drag this on what's essentially the background. That's the target. Then I'm going to simply, some people do a max, but that can lead to strange artifacts. I'm simply going to add the star mask back in. That's it. Just $T plus star mask. So we're going to pull that in right here. And the stars are restored. So this is what my result looks like. I probably need to do some noise reduction for this. Is a little grainy. In fact, we can probably go ahead and create a luminance mask, and here I can just extract it because it's already stretched. So I'm going to extract it. I'm going to, actually this time I'm doing the reverse. I'm masking the background and opening up the nebula. So let's pick the mask. I know I could drag it on, but I prefer to do this way. Okay, we'll go into our preview to start out with. We're going to do this luminance correction again. So let's do MLT luminance, but we're going to focus on the chrominance. And let's see what it looks like with the defaults. So we're not manipulating pixels, we're just manipulating intensities of the RGB channels so that we can sort of normalize this graininess that you see here. And if I zoom in, you can see that really grainy image. So we are at 2 out of 3 channels. We're at the 3rd channel processing, and it's definitely smoothed out. The pixels are probably something I'm going to need to address separately. Let me go ahead and apply this to the full thing. And we're at 2 out of 3 channels, getting there, almost ready, almost ready. And there we go. So I think this looks better as a bigger image. And I still probably would want to do some work to bring this out, but that's probably about the best I can do given the bad signal. And it's not bad. It's, again, not something I probably publish. I will go out and get more captures and bring out more signal, but I'll use something like this to experiment with, like what happens if I sharpen the whole image, and so on and so forth. Actually, that was with a mask on, but you can see those results. Hopefully that's been helpful. This is the workflow that I use for camera processing. I've showed you some of my tricks to normalize the shapes of the stars, to get rid of some of the background noise, to improve the contrast, to normalize the colors, and to even use some things like expanding the image, tweaking it, and then shrinking it back down to get rid of some weird shapes and whatnot. My name is Jeremy Lickness. I'm at deepskyworkflows.com, and I appreciate you joining me for this session.